Okay, so today is day 3 of chapter 2 notes, other types of equations. So remember from yesterday, we talked about extraneous solutions. So extraneous solutions are just solutions that are not actually valid for the question that we are working with. And this is possible when we square both sides of an equation or when we multiply both sides of an equation by a variable. You can always check your answers by taking your solutions and substituting them into the original problem. You can do that even when you don't square or multiply both sides, just to double check that you didn't make any mistakes throughout the problem. Okay, so in practice problem number 1, we are going to use substitution to make this a little bit easier of a problem. Um, Anytime that you use substitution, it's just important to remember that you do need to substitute back at the end. So for this problem, let's let y equal x to the 2/3. Okay, so if we rewrite this problem, we are now going to have y squared plus 3y minus 28 equals 0. Okay, then I can go ahead and factor that. So I'm going to have y plus 7, y minus 4 equals 0. Okay, so now I have y equals negative 7, or I have y equals 4. Okay, but now we have to remember to substitute back. So this is actually x to 2 over 3 equals negative 7, and y to the 2/3, x to the 2/3 equals 4. Okay, so now I can cube both sides. So if I cube both sides, that's just going to cancel out. So I have x squared is equal to negative 243. Okay, and if I do the same thing over here, then I have x squared is equal to 64. Okay, now if I were to take the square root of both sides, I cannot take the square root of a negative number. So this side does not work. Okay, however, if I take the square root of 64, I get x is equal to plus or minus 8. All right, moving to number 2. So feel free, if you are comfortable with these problems, go ahead, pause the video. You can complete them on your own and then just come back to check your answers. For number 2, let's go ahead and square both sides of the equation. Since I'm squaring both sides, we do need to remember to check for extraneous solutions. Okay, so if we square both sides, we get y plus 4 is equal to y squared plus 2y plus 1. Let's move everything over to one side of the equal sign. So I have 0 is equal to y squared plus y minus 3. This is not factorable, so we do need to use the quadratic formula to find out our solutions. So we have y is equal to negative 1 plus or minus 1 squared is going to just be 1, so the square root of 1 minus 4 times 1 times negative 3 divided by 2 times 1 is 2. Let's simplify that. We have y is equal to negative 1 plus or minus the square root of 13 divided by 2. So that's where we get our two solutions. So we would have negative 1 plus the square root of 13 divided by 2, and negative 1 minus the square root of 13 divided by 2. Okay, so pause the video, and you can use your calculator to check both of these solutions to see if they are extraneous or not, and then go back and unpause to see if you are correct. So if you went ahead and paused, you would find that the only answer, the only solution that is valid is negative 1 plus the square root of 13 divided by 2. Our second solution is not valid and it is extraneous. Okay, moving to number 3. I am going to go ahead and multiply both sides of this equation by t squared. Okay, so since I'm multiplying both sides of an equation by a variable, I do need to check for extraneous solutions at the end. All right, so if we multiply through by t squared, we are going to end up with 1 plus t minus 7t squared is equal to 0. So I'm just going to rewrite that, divide through or multiply through by a -1, and I end up with 7t squared minus t minus 1 is equal to 0. Okay, this again is not factorable, so let's go ahead and use the quadratic formula. So I have t is equal to 1 plus or minus the square root, -1 squared just gives me +1, minus 4 times 7 times -1, divided by 2 times 7 is 14. Simplify that, we get t is equal to 1 plus or minus the square root of 29 divided by 14. So my two solutions is 1 plus the square root of 29 divided by 14 and 1 minus the square root of 29 divided by 14. Go ahead and pause the video and let's see if either of those are extraneous. Okay, if you checked your answers, they both are actually valid solutions. So either way to write it would be acceptable. You could write them separate or you could just leave it as plus or minus. Either way is fine. Okay, moving on to example number 4. Number 4 does involve quite a bit of algebra, so leave yourself some room. The first thing we are going to do is square both sides of this equation. Since we are squaring it, we do need to check for extraneous solutions. Okay, if I square both sides of this equation, we're going to have the square root of 1 minus 2x. Sorry, I don't want that parenthesis there. Plus square root of x plus 5 times square root of 1 minus 2x plus the square root of x plus 5 is equal to 16, 4 squared. Okay? Square root of 1 minus 2x times the square root of 1 minus 2x just leaves me with 1 minus 2x. Okay, now I'm going to multiply my inners and outers, and since we are multiplying the same binomial twice, I can just shorten that by putting a 2 out front. Okay, if I multiply this, first we are going to multiply x plus 5 times 1. So that's just going to give me x plus 5. Okay, now I'm going to do the same thing, but with x plus 5 times, let's make that the same color, -2. That is going to give me -2x squared minus 10x. Okay, and then if I multiply my outside together, I'm going to just end up with plus x plus 5. Again, that equals 16. Let's go ahead and take a second and simplify that. So I'm going to have 2 times the square root of -2x squared minus 9x plus 5. And then I have minus x plus 6 equals 16. Okay, let's go ahead and move a few things to the other side of this equation. So I'm going to have 2 times the square root of -2x squared minus 9x plus 5 is equal to positive x plus 10. Okay, then let's go ahead and square both sides again. Okay, if I square both sides again, I end up with 4 times -2x squared minus 9x plus 5 is equal to x squared plus 20x plus 100. So if you're wondering what was the purpose of doing that, it was just to get rid of the square root. So we wanted to get rid of, let's highlight that, this square root by squaring it. Okay, so they undo each other. All right, now I can go ahead and distribute that 4. So I have -8x squared minus 36x plus 20 is equal to x squared plus 20x plus 100. Okay, let's bring everything to one side. So I'm going to end up having 9x squared plus 56x plus 80 is equal to 0. Okay, then we are going to factor this. So it's going to factor as 9x plus 20, x plus 4 is equal to 0. So x is equal to negative 20 over 9 and negative 4. We do need to check for extraneous solutions, so substitute into your calculator and see if both solutions work or not. And you should find out they both are real solutions. Okay, let's move on to number 5. So this one looks like a more complex problem, so we will be using substitution. The way I kind of know to use substitution for this is because I see the square root of x minus 1 shows up more than one time. And leaving the problem as is, I cannot factor. I can't really do much with that. We don't have a quadratic. I'm not really sure what else to do. So we are going to use substitution to make this a little bit easier for us. And then we have to remember to substitute back at the end. Okay, so instead of having the square root of x minus 1, it'll be easier just to let that equal y. So let's say let y equal the square root of x minus 1. So if we rewrite this, I'm going to have 2y plus 1 over y minus 6 equals 0. Okay, the next thing I'm going to do is multiply both sides of this equation by y. I'm going to do that so I can get rid of 1 over y in the middle. So since we are multiplying both sides by a variable, make sure that you check for extraneous at the end. Okay, so now I have 2y squared plus 1 minus 6y is equal to 0. Let's just rewrite that. 2y squared minus 6y plus 1 is equal to 0. That is not factorable, so we do need to use the quadratic formula. So I've got y is equal to 6 plus or minus the square root of 36 minus 4 times 2 times 1, all over 2 times 2, which is 4. If we simplify that, we get y is equal to 6 plus or minus the square root of 28 divided by 4. Simplify that a little bit further. We have y is equal to 6 plus or minus the square root of 4 and the square root of 7. So that will just give me 2 square root 7 all over 4. So then last, y is equal to 3 plus or minus the square root of 7 over 2. Okay, but now we still have to substitute back in. So we had y standing in for the square root of x minus 1. Okay, so that means that we have the square root of x minus 1 is equal to 3 plus or minus the square root of 7 divided by 2. So I do need to square both sides. So now I have x minus 1 is equal to 3 plus or minus the square root of 7 divided by 2 squared. And then just move the 1 over. So we have x is equal to 3 plus or minus the square root of 7 divided by 2 plus 1. Okay, again, you do want to check for extraneous solutions, so store that whole thing. So 3 plus the square root of 7 divided by 2, and then plus 1 in for x, substitute that into the original. You will find that it does equal 0. Then do the exact same thing, so 3 minus the square root of 7 divided by 2, plus 1, store that in for x, and find out if that is extraneous or not. It does work, so we do have 2 valid solutions for number 5.